All available experts, please report to room A9.
Hello guys, Exto here, and welcome to Serial Wires. You'll be able to tell this apart from its familiar face counterpart, complicated wires, as these bits of cardboard on the bottom, which normally have stars on them, have letters on all of them now. So we're going to note down these letters and the serial number. So the serial number is 899BC4, and the letters along the bottom, letters and numbers, is HS6X5E. The S and the 5 look quite similar there, but I think that's an S and a 5 in that order. And what we're going to do is find the minimum distance between both characters in this diagram. Note that the diagram runs around, hence why you can say that the Y7WM, for example, and the V7V7 4040 seems to be repeated across the grid. We're going to find the minimum distance between them using only orthogonal directions, aka only going across these little bridges here. So we can't go from V to P directly. We would have to go V to 4 or D and then P. And we're going to note down how many it takes. Convert that into a colour. The colour can be yellow, blue or black. And the goal of this module is to set these top LEDs to yellow, blue or black. And leave it for 3 seconds, I think. Yeah, for more than 3 seconds. Module self. So only input it as soon as you know all of the LEDs. And if you get it wrong, all the lights will turn off and you have to try selecting something different. So first let's do the first row here, which will be corresponding to the minimum distance rule. So we're looking for 8, which is here, and technically is also here. So let's mark it there as well. And H is here. And we can see the minimum distance to get from H to 8 is 1, 2. And as you can see here, minimum 1 or 2 spaces is needed. We write down yellow. So our current colour for step 1 is yellow for the first one. And we're going to repeat this for the rest of them. 9 and S. This looks like it's going to be 2 again. Let's just make sure. It's going to be 2 again. So, as reading you from the previous one, that's also yellow. Next we have 9 and 6, so we can keep the 9 highlighted and find 6. Okay, this one might be slightly more difficult to see. But 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. These all seem to be 6s. So, in this case, 1, 2, 3, 4, 5, 6, yeah. In this case, we don't really have any other options. So I think the shortest distance here is 1, 2, 3, 4, 5, 6, yeah. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 is not 1, 2, 4, or 5. So we're going to note that down as black. Up next we have B and X. B and X. As you can see here, the shortest distance is 1, 2, 3. I think. Yeah. 1, 2, 3. 3 is not 1, 2, 4, or 5. So this is also black. C and 5. C and 5. The shortest distance between these is Also 1, 2, 3, 1, 2, 3, and so on. 3 is not 1, 2, 4, or 5, so this is black as well. Finally 4 and E. 4, E. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. The minimum seems to be 5. Minimum of 4 or 5 spaces, we write down blue. And now we're going to look at the wire colours and patterns. Find the column that our pattern's in. There will be 2 patterns per column. And write down the colour we get from it underneath the current one, and then combine them in step 3. So in this case, we have block blue, which is going to be black, as you can see here. Then we have white and blue striped, that'll be yellow. White and red striped is black. Blue and red striped is blue. Solid blue is black. And red blue is blue. So how do we combine these colours? Do note that if a wire doesn't exist, we just use the value we get from this step as our final one, as we can see will happen in the next one. Just a side note, you can probably also tell whether or not this is complicated wires or not, by if you can even interact with the wires. So we're now going to look at both colours, and if they're the same, we're going to keep it the same. If they're different, we do it to the one colour it wasn't. So in this case, yellow black goes to blue. Yellow yellow goes to yellow. Black black goes to black. Black blue goes to yellow. Black black goes to black, and blue blue goes to blue. So this is the orientation we're going to be submitting. Blue, yellow, black, blue. Okay, so module. Let's do another example. The serial number stays the same, but we now have SN4407. 0 on the module, and in here we'll have a slash through it. So let's do the same process again. KTaNE. We have 1, 2, 3, 4, 5, which seems to be the smallest. 1, 2, 3, 4, 5, yep, which is blue. We have 9 and N. One, 2, 3, which we know is black, because it's not 1, 2, 4, or 5. Next we have 9 and 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This one seems to be 5. 5, as we see, is blue. Next we have B and 4. 1, 2, 3. 1, 2, 3 is again not 1, 2, 4, or 5, so it's black. C and 0. Remember 0 is the one with the slash through it, so it's this one. Let's just check there aren't any other ones. There aren't any other ones. 1, 2, or 1, 2. So 1 or 2 is yellow. And finally, 4 and 7. You see up here, 1, 2, or down here, 1, 2. 1 or 2 is yellow. Now, in this case, we only need to figure out these 4 for the second rule, because the wires don't exist for these ones. Hence, we can actually put their final colours as blue and blue here. And now we're going to fill in the rest of these. So connected to this, the second one, we have block white, which goes to blue. Black and blue goes to yellow. This one we have red, blue, which goes to blue. Black, blue goes to yellow. This one we have block red, which is yellow. Yellow, yellow goes to yellow. And finally, block blue goes to black. Yellow, black goes to blue. So our final configuration we're going to be switching is blue, yellow, blue, yellow, yellow, blue, which is going to be a lot of clicking. Okay, that's our module. So that was serial wires. It's, I think, the longest out of the familiar faces modules, if you don't include mistranslated because it's a needy or alarming because it's a pseudo needy, basically. But it's quite a simple concept. Just be careful with pairing stuff up and only submit when you know all 6. You can't set one to yellow just because you know it's already yellow. And you can set all of them to black by just cycling one through all the colours first. Because it's not beyond it for all of them to end up being off. Black can also be referred to as off, by the way. Because in normal complicated wires, you wouldn't say the LED was yellow or black, you would say it was on or off. Anyway, hopefully you understand how serial wires work now. And I see you guys in the next tutorial. I'll see you later.